another exercise in the ARM Mbed simulator. So we can start from the, not this time with the Blinky demo, but we will start with there is an temperature humidity demo. So down here, load the demo. And then it's an temperature measurement. So wasn't it that you can actually add the temperature? Yeah, you can click here to get the values changing like this. So this is like a temperature sensor in here. So it is one common type of a temperature sensor. It is connected to the pins 28 and 27. Then there is a display, which is an LCD display with that kind of display driver, which is also quite common. And it is connected to the pins 5, 6, and 7 on this ARM Mbed demo microcontroller board. And then they have a code in here. And then from the code, we can recognize that the display unit is working with the SPI communication, which is the serial peripheral interface. So that's one of the communication methods built on the hardware of the microcontroller. So it's very effective. And then the temperature sensor is, on the other hand, connected with an I to power C, C to power 2 communication. No. So, sorry, it's the I to power 2 C communication, how they read it. So I to C in here. So it's got just the data and the clock in here. It's another common communication method. And then there is one LED and a simple program. And this time with the floating point numbers as well. Not only integer numbers. Floating points are those like the exact values, 26.45 degrees Celsius in here, which you are also displaying here on the screen. And then our aim is to develop this one further. So we will be building up a thermostat so that we have it automatically turning the heating on and off. That's a thermostat. And for the thermostat, we will need a few other variables to define in here as well. So we are not only having the digital out, but we have some digital inputs as well. So we have some setting push buttons in here. So digital in, and then we name it higher button. And put that in the address B23. Then another digital input, digital in, and a lower button. And that one in the B22. Typing error there, so digital in. So then we need a few digital outputs. So digital out. And the first one is an LED for showing that we are doing the settings. So setting, right? And that's on the B24. and a heater LED showing that the heater is on. So digital out, and then heater LED in the pin number 25. And then a few integer variables. So this is the for my higher button and what it has been earlier. So I need to know that when I'm pushing the button, that if I'm pushing it for the first time, that's for the code. I mean, if I keep my finger there for a long time, like it's a push button, I keep my finger there. So it is not in every program cycle reading that I have pushed it. It will read it only when I put my finger there. That it will recognize. And later, when it is reading the button that it is pushed, it knows that I was pushing it earlier as well. So higher button earlier variable. So that's just an integer variable. And also the lower button, lower btn earlier. So and then a few floating point variables. So for the temperature, they have it in the definitions in here. That's a bit odd because they are defining it here, where they are using it for the first time. It's a better practice to collect all the variables in here. So float temp in here and float humidity in here and float temp setting. So this is my temperature setting. And for the temperature setting, I'll put an initial value in here so that it is 25.0 as a floating point. Like this. And then there was something that I was like defining already. So for now on, these are the variables that I will be using. So there is the LCD display, there's the sensor, there are the two buttons, and then there is a digital out and digital out for LED indicators. So of course now I need to import these because I haven't got their two buttons now. So I add a component. First we will need the LCD. The LCD is already there. And it is on these pins because the SPI is defined here on the 5, 6, 7. So the operating system knows that when I'm writing here SPI OC, clock, MISO, P8, P11, it knows that these are referring exactly to these pins because these are the SPI pins in here. And then that's the chip select. And the last one, I don't remember what's that. But anyway, that's defined. And then there is this temperature sensor. It is using the I2C communication, which is also defined on the hardware that it is these pins. Then there is a button in the pin 23. I need to add a component here. I add a component, a button, push button, and in pin 23. And then adding there another component, a blower button in the pin 22. So push button again, add in 22. So this is my higher, this is my lower. Does a bit like another way around. I would like to have a lower on the left and higher on the right. So I'll delete this once and add another component. Push button on the 23. So this is my lower in pin 22 and my higher on pin 23, right? And then I'll add their setting LED and heater LED. So my setting LED I add in the pin number 24, and that's a yellow LED. Pin number 24. A yellow LED on the pin number 24. So I know that I'm giving the settings when that LED is on. And then there is an indicator that the heater is on. So we put a red LED on the pin number 25. Add a component, a LED again, red one, red LED in pin 25. That's all. So now we have all the hardware defined. And then I'm modifying this coding here. Set the temperature by pushing buttons lower, higher. By pushing buttons lower or higher. And then and that's all. So the red LED is the heater status. So that's printed in the beginning. Then I need to define for the push buttons the higher button mode, because there are no external resistors that I can add there with the component. So the mode is so that means that it is off when I'm not pushing, and when I push, it goes on. Lower button. Out and pull down. So it's using an internal pull down resistor now. So there is a resistor which is pulling it down to false. And then my switch is connected from that input to the operating voltage. When I push the switch, it changes the button input then to true. What else? Nothing else. That's all. And then we go into the while loop. And then in the beginning, there is, they initialize the LCD display by writing there that I think this is LCD clear. And then what they are doing then is that they work with the defining that this temp isn't floating and so on. Of course, we need to remove these. We might use this part of code later, but we are not defining those again. So let's leave those like those are there. And then after this LCD clear, we will set the setting LED to 0. So that if we don't push the button, it is always off. So always when you come in the beginning of the loop, we have this LED off. And then we make there a test that if someone has pushed the button higher or if someone has pushed the button lower. So checking that if these are pushed. So if sentence and higher button read. Higher button read, and remember the parentheses here, and then that equals, double equal here. And if it equals 1, so then we know that we are pushing it. But I would like to know, because I'm running this loop like every a couple of 100 milliseconds. And I would like to read that if I push it now, if I'm keeping my finger there, it is not all the time reading that I'm pushing. So it's like not increasing the count of the pushes. So then that's why I put there another statement. So I put there a statement with the AND operator. So it is the double add here. And then I need another parenthesis here. And then I need to put my other statement in here and then close the parenthesis still. So, and the other statement is the higher. We had this higher BTN earlier. Higher BTN earlier. And if that equals to 0, then I know that I pushed it now. And then let's have a look at what to do there. And because this is the higher button, I set my temperature setting higher. So temp setting equals to, yeah, there is also a shorter form of writing this, but I'm writing it like this that everyone understands exactly how it works. So I'm just adding there a number 1, but it's not an integer, it's a float. So I need to add there floating point number 1. Otherwise I get an error on compiling. And then setting LED dot write, and I'm writing there 1. So it is blinking my setting LED when I'm pushing with this button. And that's all. And what is this higher button earlier? We haven't given it any value in here. So after closing this if sentence, I'm giving it a value. So higher the n earlier equals to higher button read. Like this. So now when I'm executing the loop and coming here back again, this higher button earlier has the value that what was the higher button in the earlier round of executing this loop. Right. And isn't it that we need the same kind of structure for the lower button? So now it is just a yeah, copying from here. And make this lower button. Lower button earlier. Then when we, with the lower button, we would like to decrease the temperature. So it is -1. And then lower button earlier. Reading the lower button. Like this. So this was the part of the while loop where we are setting the new values for the temperature setting by pushing these two buttons in here. So the other one is for setting the setting lower and the other one for setting the setting higher. And then the code which already exists there, we can use that one for reading the temperature. So we are reading the temperature from this temperature sensor. We are reading the humidity for this the same temperature sensor. So what is this SHT31 read humidity? It's of course a method in a class, or from that class they created the object SHT31. So, and that was defined in here. So that's the object from this class. And in there are those read temperature, read humidity methods. And then again, from the earlier code, we will be printing something on the display. So LCD locate 3.3. So I'll just a minute, this is XY. I'll write it a little bit higher. So at least I guess this is XY coordinates. And I'm printing there the temperature setting. Yeah, because that's what I would like to write there first. So it's a floating with 2 decimals, and the value is there, not the temp, but it's this temp setting from here. So that one, temp setting. And then, yeah, okay, that's all the original. I could have copied it or left the original in there. So on the line 12, I'm printing the temperature. Not the temperature setting, but the temperature. As a float with 2 decimals, and it is the variable temp, like this. And then from the original, there is the, I'll go to the line 22, or coordinate 22, and printing there the humidity. Oh yes, yeah, I was thinking about that. What is this percent in here? But it can be seen, that's the display from the original demo here. And then there is 46.45%. And then to write the percent, you need to put there the control mark percent and then the percent. And then what we are doing then, after printing those, or yes, now this is not just a temperature display, this is a thermostat. So I need to put there the controls for the heating. So I'm checking that if the room value is lower than the setting, the heating should go on. So if the temp is lower than the temp setting, then we had the relay, didn't we? We had the heater relay defined in here. Digital out. What? No, we haven't. So there is still a heater relay. Digital out. Heater relay on pin 26. Like this. So one more digital output, heater relay on the pin B26. And then it was this if sentence in here, temp settings. If the temperature is lower than temp setting, so it is the heater relay right. Heater relay right, and we write there 1, so it goes on. And what else? If we put it on, somewhere we need to put it off as well. So if temp is higher or equal to temp setting, we will then put the heater relay off. Like this. And what else? Oh yes, we have this indicator LED in here. which is showing if the heater is on or off. So we still control the heater LED that we defined in the beginning. So heater right. And what we write there is the value of the heater relay. And that value we can get with the heater relay read. And that's not ours, that was from the original example. Oops. So and wait for 0.5. I guess this is in seconds because this is not the wait, milliseconds. Right. And if that's complete, we can try to run it. It compiles correctly, and then we can start operating this one. So wait a second, my setting is 25 degrees. Temperature at the moment is 20.5. Humidity is 30. And because the temperature setting is higher than the temperature, the LED in here is showing that the heater is on. And then I'm putting the setting lower. Yeah. So if I push it very quickly, it doesn't change anything because there is the wait for half a second. I need to push it a little bit longer. And then I get it always like 1 degree lower. And you see, I'm keeping my finger here. It's not on every program cycle setting it lower. So I need to push it again to get it 1 degree lower. I'm keeping my finger there, nothing happens. I'm taking my finger off and pushing again, then it goes lower. And now the setting is 19 degrees. The actual temperature is 20.5 and the heater turned off again. If the temperature is falling in the room, I'm clicking here, 17 degrees, then the heater goes on again. It's a working code. So anyway, then the wait you need to replace with this treat, sleep, for and the value if you're using the operating system 6. Otherwise, this would work on your hardware and the normal compiler as well.